Well, hello there, everybody. My name is Shannon Bradley, and I'm a project manager at the National Center for Supercomputing Applications at the University of Illinois. Welcome to our concurrent session F this afternoon. The theme for this session is supporting education and communication. And we're going to have three presentations. Each of them should run about 10 to 12 minutes, followed by a small session of questions and answers. After all three of them are complete, we'll have a general discussion and questions and answers for the final 15 minutes of the hour. As I posted in the chat earlier, please feel free to post any questions that you have in the Zoom chat. I will look for those questions and share them with the presenters whenever we're ready. And we also encourage you to use the shared notes section in the document in Kiko chat. So the presenters have a future reference to go to about some of these questions. Also, don't forget to sign in that you have attended the session this afternoon in that document in Kiko chat. So onward and upward, here we go, everybody. Our first presentation is going to be about the Intercultural Learning Hub, or Hub ICL. The presentation this afternoon will be by Annette Benson, and this one is a pre-recorded presentation, but afterwards Annette is with us so we can do some Q&A. Our second presentation is an interactive C++ code development presentation using C++ Explorer and GitHub Classroom for educational purposes. And this will be presented by Patrick Deal and Stephen Brandt. And our third presentation is by simplebee.io, an online tool and community for communicating biology and biomedical science in plain language. And our presenter will be Arjun Krishnan. So I'm going to let Annette go ahead and take it away. Welcome, Annette.
So now you'll just start. I'm Annette Benson, and on behalf of my assistant, Lindsay McDonald, our Hub Zero liaison, Claire Sturm, and our Hub Zero stack developer, Anthony Fuentes, it's my pleasure to tell you about the development of the Intercultural Learning Hub, the lessons we've learned, and future developments in store for our hub. Intercultural Learning Hub, also known as the Hubicle, was rolled out in its final version on November 6, 2018, almost 2 years ago. Before we begin talking about the Hubicle as a hub, it might be helpful to talk for just a moment about what we mean by intercultural learning, since we were talking about the Intercultural Learning Hub. The term intercultural learning refers to the acquisition of general, transferable, intercultural competence. That is, competence that can be applied to dealing with cross-cultural contact in general, not just skills useful only for dealing with a particular other culture. Our objectives in teaching undergraduates about intercultural learning are defined in the AAC and U Intercultural Knowledge and Competence Value Rubric. We teach openness, curiosity, communication, empathy, self-awareness, and worldview frameworks through the use of experiential learning tools. Assessment, debriefing, and reflection resources are also important in our field. The experiential activities that educators and facilitators use come from a variety of sources: books, favorite consultants in the field, academia, workshops, flipping through books, Googling. But no one had ever created a one-stop shop in which you could plug in what you wanted to teach and get recommendations from a storehouse of activities. Being that one-stop shop was the impetus for the creation of the Hubicle. I had the opportunity to attend an SGCI boot camp, now called Focus Week, in the summer of 2019. It helped us to think through what set us apart from other intercultural learning offerings where people have been getting their intercultural learning training and experience. We set a goal to be both superior in the extent of resources as well as the depth of resources that we offer. When we first discussed the creation of the Hubicle, our only intention was to create a searchable and shareable toolbox of intercultural learning resources. Once we met with the Hub Zero folks, we discovered that the Hub Zero template offered much more than that. So we also created an online space for others to collaborate, as well as a research repository. However, the toolbox, that's what remains what the Hubicle is most known for. So if you were to go to hubicle.org/toolbox, this is what you would see. Down the side is a menu which allows the user to search based on the aforementioned AAC&U value rubric, as well as logistical concerns. There's also a more advanced search with more options such as stage-based pedagogy and additional skills. When users want to contribute to the Hubicle toolbox, they progress through a series of forms such as this one, filling in what they know and then leaving the rest for the Hubicle curation team to fill in. As the curation team goes through the process of fully understanding the proposed tool and preparing it for sharing with others. After a tool is published to the toolbox, it looks like this. Through a usability study supplied by SGCI with Dr. Paul Parsons and his team of UX students, we realized a few upgrades were needed to improve the user experience. For example, an open tab is now white, populated tabs are dark gray, and unpopulated tabs are grayed out in a lighter shade of gray. In addition, the user experience team suggested that some people would rather have all of the information contained in the tabs in a single lesson plan, which we now also supply for many of the tools. The experience of working with the Hub Zero team was cross-cultural communication at its best, as Hub Zero learned the priorities and language of the Hubicle team, and we learned to communicate what it was we wanted in terms that Hub Zero could translate into code. I will forever be grateful for our Stack developer, Anthony Fuentes, and our Hub Zero liaison, Claire Sturm, as they worked through this process so patiently with us. During the development, the Hub Zero team discussed how the toolbox should be designed. Should it be a plugin or a component? The team decided to create the toolbox as a component, as it would have its own functionality, its own database tables, and its own presentation within the Hub. The team started building an initial database with entity attributes and tool data. After laying the foundation for the toolbox in the Hub Zero team mapped out the toolbox's entity relationship diagram. From the foundation of the toolbox component, both teams collaborated closely to design user interface mockups. The mockups allowed the Silmar team to visualize the interaction of the toolbox and answer logic questions on how their audience would expect to discover tools and publish new tools, such as, can tools have more than one type? Or which fields are required when creating a new tool? It is worth underscoring that the launch was different from a typical hard launch in that there were no significant movements of the software or other challenges that generally accompany the delivery phase of development. Delivery of the toolbox iterations was continuous throughout the engagement. When it came time to launch the toolbox, the teams only allowed public accessibility, making the launch process seamless. The Hubicle operates on a membership model. Knowing who our members are allows us to report up the chain to those who fund us. It allows us to know who our audience is, and it protects us from the unwanted attention of those who would want to spam us. So what have we been able to accomplish in the 2 years since the Hubicle was created? It was our goal to hit 1,000 members by January 1, 2020. We were able to make the 1,000 goal on our first birthday, November 6, 2019. On September 30th, 2020, our membership was 2,414. We hope to be at 3,000 by March 1st. As of September 30th, there were well over 600 tools in the Hubicle toolbox. Over 500 of them were entered into the toolbox from the established literature on the topic, and 80 original or adapted tools were entered by Hubicle members. As the Hubicle toolbox has grown, so has activity in the Hubicle. However, it's difficult to know what people are actually doing in the hub. The Hubicle administrator side lets us know when a person's first and last logins were, but we cannot tell what people are doing once they log in. We get that sort of information from sifting through Google Analytics. Regardless, there are a large number of people who seem to like the idea of the Hubicle when they hear about it from a friend or at a conference, but there are fewer who are actually logging in and using it. As you can see by the graph, no matter how we run the numbers, it is proving difficult to get even 40% of users to return after they register. Live demonstrations, which show how easy it is to use the Hubicle, have proven to be a good way to generate returning users. When we attended the SGCI Focus Week, the activities that we did there also helped us to focus in on our target audience. Through the fishbone exercise, we came to realize that our core audience is educators involved in higher education. We make the Hubicle accessible to users from corporations, government entities, privatized organizations, and K-12 education. But we do not generally target these audiences or create content with them specifically in mind, to the exclusion of higher education. You can see that we have remained true to the targeting which was established at Focus Week, as over 75% of our active users come from higher education. From looking at the Google Analytics, we also know that 39% of our active members are coming from word of mouth. And the 27% number from conferences is good to know, as we've lost the ability to travel during the pandemic. So we're looking to create alternatives to conferences. As we look toward the future, another portion of the Hubicle is being developed, which will allow professors, teachers, staff members, and consultants to work on their own intercultural learning through a new professional development zone. With the loss of live conference presentations this fall, we've been taking advantage of opportunities to demonstrate the Hubicle at virtual conferences. We're also seeking ways to profit from backlinks, mentions in journal articles, and our own Hubicle outreaches through demonstrations of tools sponsored by Purdue Center for Intercultural Learning, Mentorship, Assessment, and Research. We are delving into the analytics to see what users are interested in, which is often information regarding equitable assessment and tools from the Toolbox that can be used in a distance learning environment. In addition, we try in our messaging to emphasize what educators might want to share with others through the Hubicle, not just what they might want to use from the hub. We are considering simplifying the process for sharing a tool in order to make the task less daunting. In closing, I would so like to express our continued appreciation to the SGCI team, which keeps us going, and in particular, Anthony Fuentes, Claire Sturm, and Nate Snodgrass, as he now serves as our Hub Zero liaison. If you'd like more information about the Hubicle, please visit us as you see on the screen. Thank you to SGCI for this opportunity.
Thank you, Annette. Does anybody have any questions? I know I would like to say, I think even though you said you were not getting even 50% return after someone visited one time, compared to the numbers I've been working at, your numbers are better than mine. So I think you're doing pretty good.
Good, thank you.
Good afternoon. My name is Stephen Brandt, and I'm Assistant Director for
Sounds good.
at the Center for Computation and Technology at Louisiana State University. With me is Patrick Deal, who is a research scientist at the Center for Computation and Technology. Today, we are going to present our investigations into teaching with a talk called Interactive C++ Code Development Using C++ Explorer and GitHub Classroom for Educational Purposes.
Okay, let me start with the motivation. And I think most of you experienced, if you teach a course for C++ programming, that major burden for the students is to set up the IDE, install a compiler, and compile the first Hello World program. And Steve and I experienced this behavior in our teaching. And we were thinking that probably we should do something to make this step a little bit easier. And so what we wanted to do, we wanted to provide a complete installation to the students without the burden of the setup. And we were looking around, and if you look at the Python ecosystem, you have the Jupyter notebooks where you can log in to a server or run it on your computer, and you have this nice web interface with these cells. And we were thinking it would be really nice to have something similar for C++ development. And what we were doing here, we were extending the Jupyter notebooks for interactive C++ development. So students could type C++ code instead of Python code into the cells of a notebook. And you can see on the left-hand side, a Jupyter notebook, and it's looking really like a Jupyter notebook. But if you look at the first cell, we include C++ headers. And in the second cell, we can define the standard vector. And in the third cell, we can just type a C++ style for loop. And you can see as the output, we were just iterating over this vector. And we were thinking to having this interactive C++ development, students can more rapidly experiment with different IDs and algorithms. And in addition, we were using GitHub Classroom to teach the students version control, because we believe it's really important and it's a really benefit if they can put this to their CV for future jobs in computer science. Can you go to the next slide? And I will go over the overview of our talk. Steve will tell you a little bit about the setup and the technologies we used. Then we will show you some prior works. We will go again a little bit more in detail over the example I mentioned previously and the motivation. And we used this tool in a course where I taught parallel computational mathematics to students last fall. And we did a small survey among these students, and they gave us some feedback, how they liked this tool. And we will finish with the conclusion and outlook.
All right, now to talk about setup. Everything that we have is contained in a single Docker image, which is about 8 gigabytes. This is rather large, but not so large that you can't consider downloading it over the internet for your laptop. If you want to use it as a student, you can run our code in a notebook. Alternatively, the same Docker image can be used to run a Jupyter Hub installation with GitHub for authentication. The GitHub authentication can operate in two methods. You can authenticate users to your GitHub server in 2 ways. One, you can put a list of the users that you want to allow onto the server into an accept list, which is maintained inside the server. Alternatively, you can provide a secret word, which users can use to authenticate their own GitHub login names. This is useful in settings where you have a large number of students and you're doing a 1-day tutorial, and you can't afford to take the time to update the accept list for each person in the room. A third mode is that you can use this with what we call create your own login authenticator. This is another authentication method for Jupyter Hub, which allows the students in a classroom for, say, a 1-day setting to create their own login names and passwords to get access to the server. The server has a number of packages pre-installed. First is Cling, which is a C++ interpreter developed at CERN as a tool for scientists working on the Large Hadron Collider. The next is HPX, a parallel programming framework developed for general purpose programming, both of nodes and clusters. It contains the latest implementations of the C++ standards and proposed standards for parallel algorithms. Finally, there's Blaze, which is a high-performance C++ math and vectorization package. It is completely portable, high-quality code. So part of the reason for this project is that the installation of Cling is not trivial. The installation of HPX is not trivial. And getting all these things to work together in a single coherent image is significant work. So let's take a look at at the way the notebooks work now from a student point of view. Students can type in code such as std out, help left inserts hello world, insert standard endl. And the first time you see code like this interpreted in a running environment, it's kind of surreal because it seems so unnatural to see C++ code being interpreted. But it's also kind of fun. The notebooks at CERN do not have any magics as part of their construction. We found it convenient to add %% write file and %% bash functionality. This allows students to create and save C++ files and compile them with a command line so that they can compare and contrast running interactively with running in the more traditional way. The problem with the Kling notebooks is that they are limited by the one definition. So, for example, if you define a function, you cannot redefine it in C++ as you could in, say, Python. Occasionally, you will encounter core dumps or syntax errors in the notebook, and these may kill your kernel and cause the loss of all work so far. In addition, there is no support for the thread local language feature in the underlying LLVM, which means that std async won't work. However, HPX async, which we have included through the HPX package, will work and is semantically equivalent. Because we thought it would be useful to provide multiple interfaces to C++, just so that students had options and we could see what kinds of things appeal to them most, we also have another interface to Kling, which is to use Kling from a Python notebook. In this mode, there is a replay function to restore your work if it's lost due to a syntax error or a sig fault, and it allows passing string data between C++ and Python. The way this works is you put %% Kling in the top of a cell, and then the rest of the code in that cell is C++ code. Yet a third interface that we provide to C++ through the notebook is through PyBind 11. So Kling is based on Clang version 5.0.0, and maybe you want a newer compiler for some particular language feature that you wish to test. The idea is to provide a C++ code and a doc comment for a Python function, and then use a decorator to extract and compile the code, and then link it to Python with PyBind 11. We'll show you demonstrations of all three of these technologies in a bit. Now Patrick will tell you about the survey.
Yes. So since we tested this tool in a course, we were sending a short survey to the students, and here the additional results and the raw data is available at the reference 2. And we were just asking them first, how difficult was it to set up Git? And we had the option easy, moderate, very easy, and somewhat easy. And you can see, since we only had 4 students in this course, it was very easy for one, somewhat easy for one, and so on. And the second thing is, we asked them, when did you start using the notebook? And one student was using it from the beginning on. 2 students were using it from the start on. One started in the first quarter, and the third one started in the last quarter. And here we have to say that at the beginning of the course, we teach normal C++, and there is no need to have the HPX library to do parallel computations. And so some students preferred to use their own computer, but once they had to use HPX, which is really difficult to install, they started to use the notebooks. And at the end of the course, all students used the notebooks, and most of them were quite happy with the functionality. But also some asked for additional feature to include, for example, some debugging functionality in the notebooks. Can you go to the second slide? And then we also asked how often they use the server and notebook. And two of them agreed that they used it often. One is really neutral, and one strongly agrees that students should use the server. And we also liked or asked how they liked the notebook as an editor. And here, one strongly agrees it's a nice feature. One student was agreeing, and two students were more moderate.
Now I'd like to show you some of the functionality. Here is a notebook we use for one of the lectures in our course. You can execute cells one at a time. So this just read and processed the IO stream library, and you can see that it does it quite quickly. This processes the stdc out hello. So this is already, we've gotten the hello world part done. You can likewise incorporate strings and define constants and print those out. Frequently, the notebook also prints the type of the object that is the result of your expression. You can get the size, number of columns, and so on. This gives you a feel for the basic functionality of the C++ notebook as provided by CERN.
And as a conclusion, we have shown a novel teaching environment adapted to teaching parallel C++ programming and source code management, and the extensions to the utilized tools to make the notebooks richer and the interactive experience more complete. And the students' feedback was mostly positive, but from a small group. And we want to add the requested features from last year's course, if possible, to the C++ Explorer. And we want to redo the surveys in the fall 2020 class with 10 students in this year. And we also put some links on the next slide because, as Steve told you, we have this Docker image for the C++ Explorer on GitHub. We have the source code, and we also have the examples for the described usage on a GitHub repo. And we also have the lecture slides, exercises, and course notes. Here you can see all the links at the bottom of this slide. And feel free to use the C++ Explorer and course material in your teaching. And we would also be happy to get some feedback if you use the C++ Explorer or the course material. And yeah, we are open for questions, and thanks for attending.
Thank you. Does anyone have any questions?
Just a very quick one. There's quite intriguing, that interactive running C++ on the fly. I'm sort of intrigued about how it works under the hood. I'll have to read up about it. But it looks like you're just, would this be, is this really just suitable for teaching basic sort of C++ syntax, or is this tool actually going to be usable for, say, teaching object-oriented design and things like that in the C++ context?
I don't see why it wouldn't be usable for teaching object-oriented design or more advanced topics.
Okay, so you can still create classes in the workbook and then just run them.
Yes, you can. In my examples in my course, I have the implementation of an n-body problem where we have a class for the data structures. We have a simulation class, and everything works. So you can teach C++. The only thing is that standard async will not work if you want to have this asynchronous programming of C++, but everything else will work. And so you couldn't do anything what you can do with C++ except of the standard async.
Yeah, and we have HPX async, so that's kind of covered.
Very nice.
I'm wondering actually what you thought of GitHub Classroom.
I couldn't understand.
What we thought about GitHub Classroom?
Yeah, I think a couple of us wanted to ask a question at the same time, so there's another one. But yeah, I was curious about your thoughts on GitHub Classroom, and did you align it or associate it with an organization or an institution, or is this your own group?
So GitHub Classroom works that users have to have a GitHub account, but you have to generate an organization, and GitHub Classroom is attached to your organization. And so you have to ask the students to join this organization. And then you can just go to the interface, and it's the concept that you have a Git repo for each of the exercises. You can include a template repo with some starting file or some template files. And then GitHub Classroom sends an email to all of the students, and they get an invitation to join the repo. And my students really liked, because before they had to send emails with the source code to the teacher had to download the email. And it was a quite nice experience. However, for the first time, and for students never use Git, it's a little bit a burden. But now, after the second exercise, everyone was able to submit, and I think they really enjoy this feature. And the positive feedback from the survey, we could not show it in the talk, was that after a few submissions, students really appreciated to do this because it's much easier. They have version control, and so they can play around. And if they break codes, they can go back. And I think it's a really nice experience, but probably the first two exercises are difficult to set up for students. But I did some tutorials, and so I think it's fine for them.
If we could go ahead and move on to the next presentation, we'll have time at the end of this for some additional questions on any of the presentations. But I would like to go ahead and turn the group over to Arjun.
Hi, everyone.
He's going to be speaking to us on Simple BIO and online school and community for communicating biology and biomedical science in plain language.
All right. Hi, everyone. So let me just move this over to a place. Is everyone able to see my screen?
Yes.
Yes.
All right. Cool. Thanks for having me here. And I'm going to generally talk about a science project that we've been working on in our lab about generally thinking about communicating complex ideas using plain language. And this is a work done by a lot of people. And I'm just talking head here, just talking for everyone. We're all from Michigan State University, belonging to the computational mathematics, science and engineering departments, and also biochemistry and molecular biology. And our daytime work most of the time is really, we are computational biologists, and we are involved in studying the genetic and molecular basis of complex diseases. And we are people who develop computation methods that involve, data science and algorithms that take advantage of massive amounts of data to build models and predictions. But in this world, I've been working on this in this area for about 16 years now. And then in this world, one of the things that I frequently encounter is this need, because of involvement in biology and medicine and having implications in health and disease. I frequently talk to people about what algorithms may mean and what do these genetic tests and all that means. And in that context, I've had a lot of opportunity to really think about how can we actually communicate these complex ideas to people, especially non-experts. And by non-experts, I not just mean non-scientists, but also even scientists who are in adjacent areas. However, the way we communicate science today, it is super hard to understand, right? So because most of the way we communicate science is through papers, textbooks, or technical discourses that are quite hard to understand. And for example, there was a 2017 study which basically looked at published scientific text from across several years, and they basically noted that the readability of scientific texts has steadily gone down with years. But science communication is extremely important, as all of you know. And specifically, technical language and jargon, however, is a big barrier to communication. And it is specifically a barrier to understanding transparency, accessibility of the science, entry into science itself, and for diverse students and general public, and also retrieving knowledge that is essential for one. So what we wanted to do is to see if we can develop an online platform for science communication that serves two goals. The first goal is that we wanted to create an online tool that will enable scientists or students to write technical content in simple language or plain language, okay? And the second goal is to see if we can develop a community around this tool that involves students, teachers, scientists, writers, and even the general public, where they can sort of exchange science in simple language, and through that process, engage in science communication and learning in some way. Okay, so these are the two goals. Today, what I'm going to talk about is what is actually under the hood of this particular tool, and then talk a little bit about our tool itself, which is in very early stages. We are not very close to releasing it to the public, but I want to just showcase our tool a little bit at the end. As you'll realize, one of the biggest problems here is that if we try to set out developing a tool like this, we need to define what simple language is in the first place, right? But when we went around and sort of looked at some guidance, most of the times the recommendations that we get are typically in the form of guidelines, rules, tips, and checklists, which is very descriptive of what simple language should look like. So for example, there's plainlanguage.gov, which was released as part of the Plain Writing Act of 2010 in the Obama's time. And it's a fantastic resource. And for example, NIH also has these checklists about how to write in simple language. But we were thinking, of course, a tool cannot do this without human intervention. So we thought, how do we quantify simple language in some way so that we can deliver it through a tool? One of the most popular ways of quantifying some simple language is through this measure called readability. Many of you might have encountered this Flesch-Kincaid's grade level score, or even the reading ease score, which is essentially the following. Given a piece of text, it will calculate the average length of all the sentences and on the average length of all the words and combine them together and map them to US grade levels. And it is very widely used. In fact, it's adopted as a standard in education, government, and finance. And it's also part of many word processing tools like Microsoft Word and Grammarly. The take home essentially is that one should use short sentences and short words to improve readability. However, we know this is not always enough. For example, this sentence here is short but super hard to understand. There are also many two-syllable words that are quite complex, and there are many polysyllabic words that are very easy to understand as well, right? So readability as characterized by this very old measure is not quite enough. Another common way of thinking about quantifying understandability of words is through this frequency, which means that words that are very frequently used are also words that are quite understandable. So this principle is used, for example, in a subset of Wikipedia called Simple Wikipedia, where one is supposed to write articles only using, either a list of 2,000 words or 1,500 words in a special list that is curated by people. Okay? So which are very common words in English. The same idea is, for example, used by Randall Munroe. He's very famous for creating this XKCD comic. If you've not read it, you should definitely read it. He in fact wrote an entire book called Thing Explainer, where he used the 1,000 most common words in English to talk about various things that are around us. So it's very entertaining, but the idea is to use vocabulary. But just using frequency is actually quite restrictive, because, for example, I'm showing you, if we restrict our vocabulary to top 1,000 words in English, we will of course get all the simple words. But just this 1,000 is totally arbitrary cutoff, which means that there are so many other words which are beyond this threshold, but still quite understandable to all of us here. These are some examples here. So what we want to do is to see if we can actually do better, which means that using frequency is good, but it's not enough. Word length is very misleading. So we wanted to say, okay, can we create a new measure about how understandable a given word is, and also develop a method that can automatically tell us words that are even field specific. For example, words in biology, physics, or chemistry that are generally more understandable than other words in that field, and sort of provide a gateway to understand science in those specific fields. So this is what we set out to do. And what we decided to do was to actually use Wikipedia to sort of solve this problem. I'm going to describe a lot of work done by this amazing undergraduate student, Matthew Artuso, who is a physics major at MSU. And the reason we went to Wikipedia is that Wikipedia, for example, has more than 6 million articles in English, but it's also frequently edited by people, and the content is generated by people, right? So this is more like trying to observe what is out there and what words people are using to describe things, and use that to get a measure of understandability of words. So for instance, what we do is to go into Wikipedia and mine all the articles in Wikipedia, which means that we are not only interested in the content of an article, but also we go to the bottom of this article and figure out how this article is actually characterized, or rather categorized, right? So for example, here, the article on cell is categorized into cell biology, cell anatomy, 1665 in science, all the way up to a category in science. So we basically take mine all this data. We are in our local repository, we now have more than close to 4 million articles and more than 2.5 million words, and divide it into a lot of different categories in Wikipedia. And using this, what we do is to essentially say that the way in which words appear in articles across all these different categories are super helpful are very indicative of their meaning and understandability. So I'm going to skip this part a little bit. I want to show you this example here. So for example, I'm showing you the distribution of how frequently two words, the words are the and the second word is leukocyte, appear across all the articles in all these categories. As you can see, the word the is more or less uniformly present in all articles, all categories, but the word leukocyte is present most frequently in health. And this is our way of thinking about, turns out this uniformity of words across categories is super helpful in terms of understandability. So for instance, the word the, because it's very uniformly used, it is more broadly understood. And the word leukocyte, because it's so specifically used, it is less likely to be understandable. So we quantified this. I'm not going to go into the mathematical details, but essentially what we are doing now is to combine how frequently a word appears and how uniformly a word appears and combine that together into a single measure. Okay. And we are calling that understandability. Okay. So now we have a measure of understandability. The second is we can sort of take this idea even further to figure out understandable words even in specific fields. So for instance, we can again go back to Wikipedia and say that there is general Wikipedia, there is science, and then within science, there are all these disciplines. So what we can use that to do is to say, we want to find out words that are very common, for example, in biology, but that are also not so very uniformly used across all of science. And that helps us in a very automated way get to words very common in biology. So for instance, this approach gives us this automatic list of these top 50 words, for example, that are biology words. These were derived using an automated algorithm. There is no manual intervention, that it gives us a nice list of biology words that one needs to know to even start reading or understanding biological science. So of course, we did this for a lot of different areas: physics, for example, star galaxy statistics, solar orbit, chemistry, computer science, mathematics, and so on. We are able to do this for various disciplines because the algorithm itself is automated. Okay. So ultimately, what we have done is to develop a measure of understandability of words, both in general English and in field specific, in a field specific way. And what we are able to do now is to go back to any piece of text, be it a scientific paper or a Wikipedia article, and in fact, directly track how much of a particular paper or an article one can understand as we walk down these words based on their understandability. And so we're able to track readability and understandability like this for any piece of text. So going back to our goal, we wanted to do all this as a form of a tool. So that's where SGCI came in, and then we basically, walked it back of the queue, and we came to the front of several months ago, and we were very lucky to start collaborating with Chun Han Yoon, who's an excellent developer with SGCI. And Janel was a high school student with our group who started some development. So with Chun Han, we have started developing this tool called Simple Bio. It was originally focused on biology. We're going to branch out into all other disciplines of science. What it allows you to do is to either directly write a piece of text or paste a piece of text, and it'll tell you which words are hard to understand based on the measures that we have developed. And then it is also an editor where you can start changing these things. And it has indicators of word complexity, both generally, maybe in a field specific way, and also gives you indication of readability in a dynamic manner. And around this tool, we are doing a lot of things like, providing Wikipedia previews of complicated words, phrases, side-by-side editor, tracking, providing a history of simplifications. And Chun Han has also implemented user accounts, collections, and requesting simplifications and so forth. Just as a caveat, I want to say that really, communicating in simple language is not that simple. That's not as simple as what I'm saying, because it doesn't just end with the idea of just fixing jargons. There's a lot about approach, voice, tone, design, and all that stuff is super important. And even more important is training, practice, and commitment to it. So we are also piloting Simple Bio and the tool itself in classrooms across MSU. in collaboration with instructors. And instructors, one of the things they tell me often is that when students use this tool, their understanding of the original content becomes even more, which is not surprising, but it's really cool that we actually see this. So I want to stop here and say that science communication is incredibly important. And it is quite, for example, scientists say that I just published some research that patients can't read. I've not written a layperson summary. I have no plan of dissemination. But scientists also say that why do patients keep visiting alternative therapies? So we need to go through the extra mile and communicate science, and our tool is to go one step in that direction. So these are all the people who did the work, especially Chunhan is doing the development. We had a tremendous amount of help from Chrissy and Brandon on developing, the looks of the interface and the flow of this interface and all that stuff, especially usability. And I want to stop here by acknowledging my entire group and SGCI for the funding and the time with developers. Thank you so much.
Thank you. Does anyone have any questions?
Yeah, I would have one. First off, really cool tool. I was looking at the website. One thing I think could be cool is if it offered thesaurus-like behavior, what it could recommend. Is that in plans or?
Yeah, absolutely. Yeah. So there are two things that we want to do. One is we are implementing a feature called Wikipedia previews, where we will automatically find hard words or phrases. And if it has a corresponding Wikipedia article, Wikipedia gives us an API to quickly preview the first few sentences of the article so that you can use that to simplify. And then we are also we are working on a thesaurus feature where for a given word, we'll provide suggestions on other words that are more understandable that it can be replaced with. It's a great idea.
I also have a question. Very nice talk. So
Hi.
is it only available for English language, or are there different languages available, or have you plans to extend it for different languages?
What an important question. So I've thought about this a lot. So right now it is English, but the way we have basically created this understandability index for both general language and for field specific, I tried to talk about the backend because we wanted to create an automated approach that starts from Wikipedia corpus. So right now, for example, what we can do is to completely switch out a language and, for example, take Spanish and do this entire thing and get indices or these measures for Spanish. So we can definitely do this. So that is the first aspect. As long as there is good representation of articles in Wikipedia, we can do this. The second is actually a slightly broader aspect that I wanted to think about. We know that automated translation is a super important area in artificial intelligence and machine learning. So for example, in Google Translate, you can stick a text and it'll give you a translation. But of course, we know that very complex scientific text is very hard to translate by automated translators. But the moment it is simplified, even automated translation becomes easier and more accurate. So I think hopefully what we also want to do is to use this tool to create simplifications of many scientific texts and use automated translation to translate it back to other languages as well. But it's a very important aspect. Thanks.
Thank you.
So there's an ultimate goal to do this for more than just biology as well?
Oh yeah, totally. We call this simple bio because we come from biology, but the moment we realized that we could just quickly just change one category setup and then get these measures for physics, chemistry, computer science, like I showed you, we want to completely rename this tool and retool this for any discipline in science.
At this point, I would also like to open up questions from everyone to any of our presenters.
A quick question for the interactive C++ talk. Did you find a lot of problems when students ran into git merge conflicts with two-pattern notebooks in C++ code?
No, because the representation of the Jupyter notebook is just some JSON file, and we never had issues. We had more issues with the C++ code, but it worked quite well. I only had to help one student who screwed up his repo. He was sending me an email shortly before the deadline for the exercise. He needs help, and I could resolve it, but normally it was quite easy and they could do it on their own because there were only a few lines they had to find to merge, but only for the C++. And I think for Jupyter notebooks, we never had issues. But we also have to say that students are not doing complicated things. They just generate a notebook. They mostly do some coding, save the notebook, push it to GitHub, and then they stay on one machine, the server, so they do not download it on different devices. So I think probably this is another reason why we do not have much merge conflicts.
So on your Jupyter notebooks, did each student have their own individual Jupyter notebooks, or were they doing interactive editing of the Jupyter notebook as well?
No,
They all
only
had
one.
their, yeah,
Please-
they
please
each
go
had their
ahead.
own. Yeah, they each had their own.
Because one of the things that we've been asked to look at is something called Design Safe, and that allows you to have interactively editable Jupyter notebooks, where multiple people can work on one Jupyter notebook at a time. And I was wondering whether anybody else was running into requests for this.
No, not for our course concept, because I share normally my screen and student can ask questions if I do a live coding session during class or during Zoom, and they work on their own.
I wonder if Google Collaboratory has this feature or not. Would you know?
I do not know, sorry.
Okay.
Any other questions from anyone? Well, this is the last session of the day, so you get to wave goodbye to my bright, shining, smiley face. The next plenary tomorrow is titled Usability, and it is featuring Paul Parsons and Hiram Kirkendall. And it will start at 1 p.m. Eastern Time, 10 a.m. Pacific Time tomorrow. So have a wonderful evening, everybody, and we'll see you tomorrow at the plenary.
Thanks, Shannon.
Thanks,
you all
bye.
presenters and for everyone for coming. So thank you so much. Have a good evening.
Bye, everyone.
Bye, everyone.
Bye.
Thank you all.